So here to talk through the Sunday Stumper by Murat Can Tonta, which is an acre puzzle with a squares theme. The whole grid's divided in these 5x5 groups. I guess only the center 5x5 group is intact. But then within those we have 3x3 squares. We've got a 16 cell frame on the top and bottom, and we've got some 8 cell frames surrounding those 9 cell 3x3 boxes in other parts of the grid. I think there are a few simple and then a few not at all simple things to see, but let's start with these cages that are very low in count. One of these in any 1x4 box will always have to be shaded. So these sort of two forms of that thinking will immediately tell you that we have to leave these unshaded. The shaded cell is one of these in blue. Acre roll of no 4 in a row gives us this cell. Same exact pattern applies down here and gives us 2 shaded cells from the no 4 in a row rule. The 7 cell cage is effectively the opposite of that. Sorry, the 7 shaded cell in an 8 cell cage is the opposite of that. We'll have to shade these, and the unshaded cell will be one of these in the middle so that we don't get 4 shaded in a row. Doing that start gives us a little more actually in the upper left, so maybe this is where we want to be beginning. Puts these in. This 5 cell cage now has 2 more unshaded cells to take, and one of those unshaded cells is in this set. So then across this whole 1x5 stretch will be the last unshaded cell, and so we'll have to be in the middle. And that actually puts in this shaded cell for connectivity, puts in this shaded cell, puts in this shaded cell. Looking across, I guess the center is now worth thinking about. So there are 2 unshaded cells in this, this group. One of them is going to have to be vertical here because of the shades above, and one will have to be vertical here, so all of these are shaded in. So that means this is shaded off for no 4 in a row, this is shaded in, this is shaded off. We know for sure that one of the unshadeds is in one of these 2 cells, and that means that the remaining unshaded is here, but notice what it will do. Whichever it isn't, whichever row it's not in, 3 in a row will be shaded, so we have to have a cell on the left and a cell on the right in the same row. Be the last unshaded. So we actually know then that this is shaded. We've got a pairing here and a last one here. And if this is to the left, then down here this will be to the right. Essentially we're going to be dodging the same row or column for the last unshaded in the space. That progress in the upper left has given us some good notes in the middle of the section. So let's look at this region. I think we could have done something more of this at the start. In part, you can break it out into something like 4 1x4 groups. We actually now have 2 of the unshaded cells marked, which means that another unshaded cell is in, for instance, blue, how I've marked it here, red, how I've marked it here. That could just as easily be marked this way. What you'll effectively see is that if we mark in what's in white and doing one of those shadings, you'll end up that the 4 corner cells, and only the 4 corner cells are left unshaded. Everything else is shaded in this pattern for the puzzle to work out. Let's sort of see what that might mean in the upper right, where we have a little bit of a start. Let's say I don't take this cell, then 3 is going to connect through these, and the rest of this is blocked off, and we've isolated that part of the grid. So we do take this cell that's a 4. We still have to figure out how we get sort of connection through the rest of the grid. So let's think about how we work through this box and say, does this cell in blue connect through this cell in gray that's in the upper left of the 4? If it started, for instance, here, I'd have to come here and then actually dodge and move over. And by the time I've shaded 4 cells, either this or this, I'm nowhere near an edge. I also haven't connected to this. This isn't going to work. If I even start from this cell, notice that I have a few ways to connect up to this gray, this path, but that marks this off, and so there's no way for this to extend. I've got this, but I can't take this cell because of the shaded one there. I've got this, but that's 4 in a row, so this doesn't work. And so this cell, which could in theory connect to this in 4 moves, can't get out of this cage in 4 moves. So we don't know which of these in blue is used yet, but we do know it's going to have to come like over here or over here and escape through a different edge. It's not joining up with this 4 in doing this work. And one thing to then note about that is this cell will always have to be taken. And if you actually think, could it be like 3 in a row could get all the way out here before it extends, it can't. So it's not just this cell is taken, this cell below it is taken, which will help us pretty quickly because with this group being different on the lower right from upper left, the remaining cell for the 3 will have to be one of these 2, it looks like, to get out of that cage, and we can mark the rest in this whole group as unshaded. Do you know any more than that right now? I don't think so, except that we'll have to connect through this to make this work out. Come over here. That looks like the right start after we knew that this group and this group used different exits out from the 3. This 2 now has just one more space to take, and what you'll actually see with some of the unshaded cells is that the shaded cell that remains for it is going to be one of these 3, for instance, just off this, but it actually can't be this. It won't connect to things, so we can mark the rest on as unshaded. This 7 now has one of its unshaded cells marked, so we still have to figure out where the other will be, but it's going to be filling in large spaces. This 2 can connect over one more to the left, and this may be where we need to figure out some more about this 19 in the center to really make this work. So we haven't thought about this 19 yet, but it's another very interesting cage. It has 6 unshaded cells to take in it, and we can do the thing we've done before of like dividing this into 1x4 squares. 1x4 squares times 6 is 24 cells, so however I do this packing, I will always leave one cell unused. And if you think about that carefully, you'll have like this pattern or this pattern with a slip mode, but it's the corner cells that will be left behind. So first takeaway is that you will always have to be shading these corner cells. If I leave a corner cell unshaded, then I have 24 cells I can tile with 1x4 groups, and I would have to have 7 unshaded in this whole region. And so there's maybe a little more I can actually think about here. And maybe this is doing a kind of Latin square constraint. I can only have, if I've got one unshaded here and here and here and here around the edges, let me use a different color for that, then I can only have 2 unshaded in the center. And what that will mean, let's say these are the 2 that are unshaded in the center, I will have a full row. I'm running out of colors to show you something. I'll have a full row and a full column in this 3x3 space that are not used. And that means that the actual placements for the 2 unused cells on the outside will be paired. The same row will have 2, the same column will have 2, and the other unused rows and columns will be where in the center 2 cells go. So there's some intuition. I'll probably leave just what's in purple here just because it's useful to keep in mind, but there's some intuition about the pairing of these placements as we get into the middle of the grid to remember about the 19. But for sure, these corner cells being shaded, easier deduction gives us something right away here. Marks this in, marks this off. We're going to need to have one of these 2 cells be unshaded, which is the last unshaded for the 7, so these get marked through. I can say that I've got a gap here and some gaps here. I actually didn't notice this yet, but I've got 3 unshaded in a row. This is one of the problems with this style, or slash fun parts of the style, is you'll not recognize when you got the Aqre rule working out. So these get marked in for sure. This gets marked off. Got to come through this cell to make this connection work. That finishes 4 in the box, puts this in, puts this out. Marking in the cell gives me 2 of this whole stretch of 3, and I'm going to need to have a shaded cell in one of these. So none of these are shaded, so this is marked in. That's now going to limit the 2 pretty quickly. The last shaded cell for the 2 will have to be somewhere like this 1x4 box. So this is unshaded, this is unshaded. And with this X marked, I think we now have set up a connectivity issue if I don't take this cell. So let me just confirm that. I can't come through here, I can't come through here, and there's a divide there. Yep, so this must be taken. This is left untaken. And so this is maybe my first cell in the purple space, but remember the opposite sides must be shaded. We don't know more than that for right now, but this is a start. And for connectivity, actually I'll take this cell, which marks this off. It means I can't ever reach to this. I can reach to this. This gets in. This gets marked off. This gets shaded. 3 in a row, not 4 in a row, puts this into the grid. These 3 coming down gives me this cell. I've got to connect into this 5 with whatever's coming from the 2, so it's got to be one of these in red, so I'll mark these in. Maybe more to do down here, but I might as well come to a group I've never looked at yet, because there's another really interesting deduction, I think, around this. So this has a single unshaded cell. We've mentioned something like that in other groups. What that means is if all of these are shaded, then there are effective unshadeds in the other rows and columns that don't include the purple unshaded cell here. And that will mean we always are canceling 4 above and below and 4 left and right of the 16 cell cage. So I guess I just had that up, so maybe I should have said it before I canceled it, where we've got kind of 4 that will move around based off purple. I have the 4 corner cells I must always be taking, that regardless of where purple moves. Like if purple moved up here, the equivalent thinking would now have, you know, these cells potentially used, but the rest in green. But the corner cells are always taken in all those models. And so having the corner cells marked will maybe give us some paths to progress pretty quickly, including the fact now this corner cell in the lower left has to take this or this as a shaded cell, which sort of means the space for the unshaded or just any of these 5 cells. These must be shaded. And what does that actually do? It means this can't be shaded. This is unshaded, which means this can't be the unshaded cell. We get this. This now is isolated. Take this cell here, which means this cell is taken here, which means the unshaded is one of these 2. Marks these off. Do we have more than that yet? It may have to do with how we get through here. So let's sort of see. If I take this cell for the 2, it would quickly close off this and close off this, and I'm not getting to the rest of the 5. So this is not usable for that connection. This then is forced for the connection. This is pretty involved, but looks credible so far. How does this 6 work? So this 6 has one more unshaded cell to take, and that's going to have to be, as we've done before, effectively one of these 3 off this shaded cell will have to be left unshaded. So this is shaded, this is shaded. Let's say I even leave this unshaded, then I have to come through here, and I'm going to have to also take this cell to be connected because of that X. That's not going to work. So I think I also know I take this. Whichever is unshaded is going to come down like this, so it's going to form this S shape. If this was the other pattern, it would come up here but form that 2 shape. So I effectively have an either or, and I always have to take this cell. So I'm going to take one of these and one of these. I still have to make the whole connection work. So let's say there's an issue. Let's say I don't take this cell here. Then I would have to take a long path. Let me show you what I'm thinking about. If I don't take this here, I'm not coming through this channel. I'd have to come through this whole channel to get connected, and that's far more than 5 cells. So it's forced to take this cell, which marks off this, marks in this, marks off this, marks in this, marks off this, marks in this, and those are 5 in the region. So this is all connected, coming through. That looks okay. We still need to figure out some stuff down here, but maybe we'll make use to have some headway up above. Something I didn't do, but I'm seeing I should do is after I mark this unshaded cell in, I know these rest are shaded, and that will help me a little bit. Marks this off. Let me put in some of the stuff I know. I've got 2 paired here, 2 paired here, and then another somewhere in the space. But I also know coming off this channel, I have sort of gaps like this. And I think that's the key observation. I can't shade this cell because I have nowhere to then take it. So I leave this unshaded, that forces this unshaded, puts this in, and this in, means that's the unshaded cell. This is the shaded cell. That marks this off, and as we talked about before, the thing all the way across is squares, and the other one marks this in, marks this in. We're going to have the alternating pattern here. The middle bottom of the grid now has to get connected out. Actually, these are probably the best place to start. This will have to come over to the left to get connection. That completes these spaces. It actually puts in this cell. We may have some additional up down to do. Actually, here it is. We've got 3 in a row here. So puts this down, puts these up, puts in these shaded cells. And that's going to give me now some more effective constraints right around the spot. It actually means I have to use a cell around this 3 for connection. So one of these will have to be shaded, and then I only have 1 more to shade in this whole region. On the bottom, coming back to the 6, I had 3 in a row, so I've got to come up through here. I'm going to have to take one of these 2 cells. I think maybe a key thing is to think through how would we make this 5 work out if some cells aren't taken, And that may begin by seeing I've got to shade at least one of these two, so I shade this. So I've got 3 more to go here. Let's say I don't take this cell. Let me see if this works. I'd force 3 in immediately, which will complete the 5. It forces this in as a set. That actually looks okay, but I can't get out of this 5 region when I'm doing that. So the issue is going to be connection out of the 5. And with a cell like this marked off, I have to put in these, but then I can't, in making this column, get out of the grid. So this cell, for instance, is shaded. That means this is left, there's a gap there. Let's say this is unshaded. I think we get the same issue, but in a different way. No, actually, then I can still extend up. But how would this go? That's a valid 6. We've got 5 cells. That looks good. I would have to take this cell. The issue may be the other way. If I don't take this, then I have to take these, which now is the 5 in that whole space, which puts in this, and now I can't connect these because of 4 across. So this cell can't be left unshaded. The cell must be shaded, so this must be left unshaded. It forces that first pattern I ran into, which puts this to the grid, puts this for connection. These can't connect if they come just to the left because this region has only 3 cells, so this has to go here. That marks off this in yellow, but means this is forced. This is also forced. The last unshaded for the 7 is one of those cells, so these are shaded in, these are shaded in. Marks off this, marks off this. This 3 region now only has a single one left to take. And it's going to have to be like one of these two, or we're going to have too many unshadeds in a row. And that means for connectivity, I've got to take this, which moves this up, and as we said, moves this up because that's how the space is going to go with the remaining unshaded for the 7 and these other 2 cells. For connectivity, we actually now have to come through this channel, puts this as unshaded. Here we've got 3 becoming 4, so that looks okay. This coming in marks this off, which forces the other to the right, puts these in. This shades off this cell, and I've completed that 3 region. So I've got to have everything else connect, and in this case I've got a kitty corner, so if I don't take this cell, I've got a disconnection. If I don't take this cell, I have a disconnection, and the only last cell to fill in this box to complete the group is right there. So we talked our way through the whole grid, a really brilliant Sunday stumper by Murat. It again highlights some really great things Aqre lets you do. These big regions, like even this 19 or this 8-8, have some very interesting character at play with how the patterns have to work. Eventually, as the left and right sides feed into them, is where you actually force the logical deductions near them. But a really good interplay of the clues, good interplay of thinking about where a few of the shaded or unshaded cells in different spots, and then having those propagate forward. So hopefully through this video you got a sense of how to work through this puzzle, and I really hope through this whole week of Aqre Puzzles you enjoyed a new shading style that we're going to keep bringing more of through this year and in future years to Grandmaster Puzzles. So thanks, we'll see you again soon.